Hi, kids. I'm going to do a little short instructional video on second law of thermodynamics. Second law of thermodynamics talks about entropy. So let's talk a little bit about entropy. What is it and that stuff. But the second law of thermodynamics says, hey, or at least one of the indications of it is, because this video is really about entropy, is that entropy for an isolated system never goes down. Okay, it either has to stay the same or it has to increase. Another way of thinking about this, and I think sometimes if you think about like entropy in terms of this, I think it will help you conceptualize a little bit better. That this is the one law that tells you which way time passes. You know, if you look at most physics laws, you don't really know which way it's going. Like it could run backwards just as the same as it runs forward. Where this tells you, hey, you know what? Like things have to run in the forward time. And here's what I mean by that. So entropy is kind of the state of disorder of a system. You can think of it that way. But again, I think if you think of it this way, it will help as well. Let's say that I have this container. I got a container. And let's say I add a whole bunch of molecules to this container. But I only add them on this half. Okay, so the container starts like this. So I have all these molecules in there. Well, guess what's going to happen? Like over time, those molecules are not going to like hang out together. They're going to spread out, and we're assuming this is a gas molecules. They're going to spread out and fill up the container because it's a fluid. Fluid fills up its container. So like this tells you, if you were to look at this, this has more entropy. Okay, why? Because it has more disorder. Or if you like, and this is where I think this will help you. Like it's really obvious time is flowing this way. I would never have these random gas molecules floating around here and just randomly look at it and at one point find them all bunched over to one side. That would never ever happen because time flows this way. So like this is flowing in such a way that the entropy is increasing. It's getting more disordered. So like I think that will help you. Another way of thinking about it, if it helps, is that there's some problems in this unit. We've done a lot of this stuff where it's like, hey, you got hot, you have cold, okay? And that we know if you put hot next to cold, the zeroth law, the Dön law, that heat flows that way, okay? Which means you're going to end up with this kind of warm blob. So then the question is, well, does the system's entropy increase, decrease, or whatever? Well, if you think about it, like, it's never going to go from you have this warm object, and then spontaneously it splits up into a hot object and a cold object. That just would not happen. So that I know time is flowing that way. So if I know which way time is flowing, like as long as it's an isolated system, well, that means the direction of like later on in time, that's increased entropy, okay? Where earlier in time, that's decreased entropy, okay? There's more order here that's organized better. There's more disorder there, okay? So I think if you think about it that way, that will help. And then the last thing I'll just mention to you is that I think sometimes also if you think about like, hey, I have a solid, okay, where everything is very, all the molecules are very, very organized in that solid. Okay, well, if I heat that solid up, okay, now my molecules are going to have a little more disorder. And then if I heat that liquid up, now my molecules are going to have even more disorder. If you think about like this, that, like going this way increases your entropy, then if you have a gas and you're going to compare another gas, just keep going that way. So like the higher temperature gas, the more disordered it's going to be. The lower the temperature of the gas, the more ordered or the less entropy it's going to have. So like As you increase the temperature of the gas, entropy goes up. Okay, as you decrease the temperature of the gas, entropy goes down. Just like, well, if I keep decreasing it, eventually it's going to become a liquid. Well, that's less entropy. If I keep decreasing it, eventually it's going to become a solid. That's less entropy. It's more organized. So I hope that helps. Bye, kids!